All right, let's go. Day 1 MCAT 2019. All right, first of all, we have a substitution question. 2x to the 4 minus 3x plus 5. And we want to know what the value of that is when x is negative 2. So we're going to put negative 2 in. Negative 2 to the 4 minus 3 times negative 2 plus 5. So they're just testing, they're probably always going to give you a negative. They're testing your kind of your number skills here on this first one. Do you understand the order of operations and how the signs manipulate? Well, negative 2 to an even power is obviously going to be a positive number. So negative 2 to the 4 is 16. So we've got 2 times 16. And we've got negative 3 times negative 2. So that's just going to be plus 6 and plus 5. So you've got 32 and 11, 43 as your answer. Okay. Question 1b. We're solving 10x squared minus 27x minus 9. Okay. This is going to be a tricky one to solve because it doesn't have a common factor through all the terms. So we're going to have to use that trick. First term times the constant, negative 90. What factors are negative 90? Split or add to make negative 27. So negative 30 and 3. So 10x squared minus 30x plus 3x minus 9 equals 0. And we've just split that negative 27 into two parts. We can now factorize this half easily. So 10x times x minus 3. And we can take a 3 out of this side. 3x minus 3. So we just factor each side independently, and you'll realize that you're going to get the same bracket. That's one factor. The other factor is 10x plus 3. This equals 0. Now we're asked to solve. One solution is obviously 3. When x is 3, this goes to 0. And then 0 times anything is 0. The other solution is a little harder to solve. It's negative 3 over 10. Opposite sign over the coefficient on x. 10 times this is negative 3. And negative 3 plus 3 is also 0. So it's going to be equal to 0. All right. What we have here is we have an exponential problem. So we have 36 times 6 raised to the power of 2x plus 6 and 6 raised to the power of x squared. So we can't manipulate these algebraic problems until the base numbers are the same. So we're going to get the base number to be 6. So 36 is 6 squared. That's multiplied by 6 to the 2x plus 6. Make that 2 bigger. And that's equal to 6 to the x squared. Now we know that when the bases are the same, we can add their powers. So that's just 6 to the 2x plus 8. And that's equal to 6 to the x squared. Now that the bases are the same, and we know that these two sides are equal to each other, it just means that the powers are equal. So 2x plus 8 must equal x squared. Solving this, it's a quadratic, so we're going to need this to be equal to 0. So we're going to subtract 2x, and we're going to subtract 8 off both sides. So factorizing x minus 4, x plus 2. One solution is 4, and the other solution is negative 2. And that is probably going to be a merit question, maybe even an excellence. So I think that's going to be an excellence question. So over the page, we'll probably find another opportunity for excellence. Okay, well, the perimeter of the lawn is 290 meters, and we want to find x. So the perimeter of the lawn is, I got a highlighter. No, I'll use this. Use the green pen. This is the perimeter of the lawn. That side, that side, that side, that side, that, and that. That's a lot of sides to be adding up. However, we know that this side and this side is 8x plus 3. And this side is 8x plus 3. So 2 lots of 8x plus 3. It's going to give us these horizontal dimensions. And similarly, 2 lots of 6x plus 2 is going to give us our 4 vertical side lengths. And we know it's equal to 290. So expanding, 16x plus 6 plus 12x plus 4 is equal to 290. Collecting like terms, 28x plus 10 is 290. Subtract 10 is 280 and divide by 8. 28x is 10. They're always going to give you nice numbers on for those ones there. They're not testing your number skills in the MCAT so much. It's all more about your algebraic process. Okay. Find the area of the lawn. So let's make this a lawn. Find the area of the lawn without the flowers in the garage in terms of L, given that L is x squared plus x plus 1. So what I call this is I call this a link. They're linking L with x via this relationship of x squared plus x plus 1 is equal to L. So I think the first thing we want to do is just get the area of the lawn in terms of x. Well, that's going to be the massive rectangle, 8x plus 3 multiplied by 6x plus 2. And we're just going to take away the flower bed, which is an x by 2x minus 5. And we're going to take away the garage, 3x minus 2 times 2x plus 1. Alright, let's expand and simplify this right down as far as we can go. 8x times 6x, 48x squared. 8x times 2, 16x. 3 times 6, 18x. 3 times 2 is 6. Now we've got to be careful, we've got negatives out the front here. So I'm going to have 2x squared, but it's going to be negative. I'm going to have negative 5x, but again another negative is going to make that plus 5x. Now I'm going to have 6x squared. 3x times 2x is 6x squared, but it's negative. Then I'm going to have 3x times 1, but again negative. Then I'm going to have negative 2 times 2x, which is negative 4x, but that's negative, so positive 4x. And negative 2 times 1, but it's negative, so plus 2. Now let's collect up all our like terms. 48x squared minus 2x squared minus 6x squared is 40x squared. 16x plus 18x plus 5x minus 3x and 4x. We want to add all those up. That's 40x. And now we have 6 and 2. That is 8. Okay, well, we've almost got the area in terms of L. We have got 40x squared, 40x, but we don't have 40. So if we have a look at that, let's factorize out the 40. X squared plus x. Let's just have that 1 in there. That's 40L. But if you see, if we expand this, you can have 40x squared, 40x, so that's good. That's what we want. But we don't have 8. Okay, we've got 40. So how do I get 8 from 40? Well, I'm going to have to subtract 32 on the outside. You can see now that we have 40L minus 32. 40L minus 32, and that's your answer. So, hopefully that makes sense, that last bit there. We just had to find this equation in here, and we just did a wee counter by subtracting 32 to bring us back to 8. Okay, question 2. Rearrange this for P. So W is P times Q squared plus R. We're going to subtract R and divide that Q squared, and that's equal to P. So we've rearranged for P. It's pretty easy. This is looking like an excellence rearrangement, and we're rearranging for k. So we want k to be equal to something, basically. So we need 1k, and we need to have no powers. I've got 2k's. First thing I need to do is, you can see I need k on one side. So let's just subtract 16gk squared. If k squared minus 16g k squared, and I'm going to add the 9c squared to the other side. Okay, I've got k's on one side. Now I want 1k. How do I get 1k here? Well, if I factorise it out, it will just be 1k term. So k squared factored out, f minus 16g is equal to 4d squared plus 9c squared. Great, I've got 1k. All right, I want to get everything off the k, so let's divide out by this. K squared is equal to 4d squared plus 9c squared over f minus 16g. I've divided, so that's a fraction, and I don't want to have powers on here, so I need to square root both sides. So k is, I write what's going in the square root first because it just makes it a little easier. 4d squared plus 9c squared over f minus 16g as a fraction, and this is square rooted. And remember that the square root of anything, say 16, is 4 and negative 4. So I might just put the plus minus on there as well, just to be a bit more accurate. Okay. Yeah, that's an excellent rearrangement. All right, next up, we're simplifying 3x squared plus 9x over x squared minus 9. Classic, just factorise your numerator and factorise your denominator, and there's usually be something you can cancel out. 3x comes out of the numerator, leaving x plus 3, and the bottom is a difference of two squares, so it's x minus 3, x plus 3. Anything divided by itself is 1, and we don't write multiplying by 1, so that's just 3x over x minus 3. Nice and easy. Cool. Alright, simplify 8x minus 1 over 4 plus 3x minus 5 over 3, and I haven't given myself much room there, so just bring this bit of paper over. We can't add or subtract fractions until their denominators are the same. We could make the denominators 120, or we could make them 24. These are all multiples of 4 and 3, so we could just scale them, scale each fraction up equivalently to something with similar denominators. But usually the lowest common multiple of the denominators is better, so 12. So we're going to put these both over 12. Once they're both over 12, we can then add. So how do we make these over 12 but retain that they're the same fraction? I've got to scale this one up by 3, 24 minus 3, and scale this one up by 4. Oh, that's an x. 12x minus 20. Great. Now that the denominators are the same, we can add. So we're going to get 36x minus 23 all over 12. So denominators are the same. Now add. Easy. Okay. Here we have an excellence question. We want to find y so the areas of these are the same. Okay. So we could put 0 in, but we're going to have a negative length, so we could guess and check, but that's going to take us a while. So let's just get the area equations and equate them. So the area of a rectangle, base, times height. Alright, area of a triangle, half, base, times height. Okay, there's two ways we could go about this. We could put this half into this bracket since they're both even numbers and have y minus 1. Or we could just multiply both sides by 2 to get rid of that half, because it's going to make this quite tricky, isn't it? I'm just going to multiply both sides by 2 because it's probably the easiest thing for you guys to see. So multiplying this side by 2, we're going to get 4y, 3y minus 1, multiplying this side by 2, it's going to cancel that half. 2y minus 2, 5y plus 9. Alright, now we're going to just expand and simplify and see what's going to happen there. So 12y squared minus 4y is equal to 10y squared, 18y minus 10y, and minus 18. We'll collect our like terms. 12y squared minus 4y is 10y squared plus 8y minus 18, and it's a quadratic. We need this thing to be equal to 0. Okay, so I've got more y squareds on the left, so I'm going to subtract 10y squared off both sides. Subtract 8y and add 18 to both sides. Nice, this is a good example of having a common factor in everything. What happens if I divide everything by 2? I get y squared minus 6y plus 9. And that's going to be equal to 0 because 0 divided by 2 is also 0. And what we find here is a perfect square. So when we solve this, or when we factorize this, we'll get a perfect square, which means there's only one solution. Y equals 3. So when y is 3, the areas of these are the same. And we could do a quick check of that actually. Y is 3, you're going to have a 6 by 8 rectangle, and your triangle is going to be 15 and 9, it's going to be 24 by 4. So half base times height is 48, and 6 times 8 is 48. So they do both have the same area when y is equal to 3. And that's an excellent question done. Awesome. We're on to question 3. Okay, when 20 is divided by my secret number, I'm going to call it x, and then 7 is added to this, this gives a solution of 2. I just write it as I read it. When 20 is divided by my secret number, then 7 is added, this gives a solution, or equals 2. Okay, so what I'm going to want to do here is subtract the 7. 20 over x is negative 5. You can see that it's going to have to be negative 4. Or you can do what I call a switch, switching those. 20 over negative 5 equals x, shows that negative 4 is equal to x. Okay, nice and easy. Don't need to spend too much time on those question A's. All right, let's expand and simplify this. This is a linear inequality, so probably mirror it. 30 minus 12x minus 20 plus 12x greater than 5x plus 20. Let's just double check I did that right. 6 5s are 30, 6 times negative 2x is negative 12x, negative 4 times 5 is negative 20, and 4 times negative 3 is negative 12, but it's negative, so we've got a double negative there cancelling out. Alright, well, negative 12x and 12x are going to cancel, and 30 minus 20 is 10, so 10 is greater than 5x plus 20. Subtract the 20, negative 10 is greater than 5x, and divide by 5, negative 2 is greater than x. There's your solution. That's not too bad. That's a merit question. Just be careful, did I at any stage divide by a negative or multiply by a negative? No, that is the only time 3 is greater than 2. The only time that the inequality changes is when you multiply or divide by a negative. So when the signs change, you'll see that now the negative 2 is greater than negative 3. So that's the only thing you need to be careful of. Okay. I think these are the last two. No, there's one more behind this. We are wanting to solve x plus 12 over x plus 4 equals x plus 4 over x plus 2. All right, I'm going to multiply both sides by x plus 4 and x plus 2 to get rid of the denominators. So if I multiply this side by x plus 4, that's going to go away. And when I multiply this side by x plus 2, that's going to go away. Okay, but the opposite sides still need to have that term multiplied. So this is going to be x plus 2, and this is going to be x plus 4. So multiplying both sides by x plus 4 gives that, and multiplying both sides by x plus 2 will give that. So there's our equalities. It's cross multiplication if you're more of an algorithm person. All right, let's just expand and simplify. X squared plus 14x plus 24 is equal to x squared plus 8x plus 16. Oh, the x squareds are going to cancel straight away. I'll subtract that. Subtract x squared off both sides. Subtract 8x off both sides. And subtract 24 off both sides. Should give, what's that going to be? Negative 8. And x is then dividing by the 6. And then simplifying that fraction, negative 4 over 3. So quick recap, multiply by x plus 4 and x plus 2, cross multiply, okay, and it gives us these. Expanding, and then we could subtract x squared off both sides, subtract 8x to get our x's to the left, and subtract 24 to get our numbers to the right, divide by 6, and then simplify that fraction. Cool. All right, here is kind of a more traditionally year 12 math problem. It's a linear, non-linear, simultaneous equation. So we're trying to find the points of intersection. Now, points of intersection are interesting. They are where the line and the curve have the same values. So basically, where are these two things the same? And what symbol do we use for the same? Equals. So where is the line 8x plus 4 equal to 7 plus x minus 6x squared? They're giving this to you in a different order just to kind of throw you off and make it tricky and test your thinking skills. But we're pretty happy with making this equal 0 since it's a quadratic, it's got a power of 2. So we're going to add 6x squared because we want to keep that positive. We're going to subtract x, and we're going to subtract 7. Now we have to solve this. Now, unfortunately, this doesn't have a common factor since 7 is a prime number. So we're going to go back to that trick. First times last, negative 18. Factors of negative 18 make 7, 9, and negative 2. So we've got 6x squared plus 9x. Doesn't matter which order you split that 7. This way is going to work. If I had these two written around the other way, that would be fine as well. There's my split. Factorise the left. 3x gives 2x plus 3. And factorise the side. Negative comes out. 2x plus 3 equals 0. These ones usually get year 11 students because they forget that there's a negative, that's a 1 there. So there's one bracket, 3x minus 1, and there's our other bracket, 2x plus 3, and that's equal to 0. Now the question just wanted the x ordinates for this. So just one of those x values for those ordinates. So one ordinate is 1 over 3. That would be the right-hand side once it's positive. And the other ordinate would be negative 3 over 2. If you did want the corresponding y's, you could plug those back into either equation, but the straight line's probably going to be a bit easier. So we're going to get 8 lots of 8 over 3 plus 4, so 20 over 3. I did that kind of quick. 8 over 3, and then 4 is just 12 over 3. So 8 over 3 and 12 over 3 is 20 over 3. And then if we wanted this corresponding y value, 8 times negative 3 over 2, well, that would be negative 24, because negative 3 times the 8, negative 24 over 2, or negative 12 plus 4, negative 8, I think. And it looks like that's about right. So there we have it. One more question. Okay. So I think because this is a 2019 one, the 2021 did a very similar question, but they did a non-linear equation. They used a unknown parabola with unknown coefficients. This one predated that, so they've just gone that one step further. So this is a linear equation with 2 unknown coefficients. The next year's MCAT, which I've already posted, they did an unknown quadratic with 2 unknown coefficients. So who knows, maybe it's a cubic this year in 2021. Anyway, this is some line, and we know that negative 5, negative 10 satisfies the equation, and 9, 11 satisfies the equation as well. So if we plug these values in, that should make this equation true. So negative 10 for y, so negative 10q equals, and negative 5 for x, negative 5p plus 5. If that value is put into this equation, it should retain that equality. Similarly for 9 and 11. So we're going to get 11q equals 9p plus 5. Right, we've got a simultaneous equation here with none of our coefficients being equal. What could we do? I'm going to multiply this one by 11 and this one by 10. Let's have a look at what happens there. We're going to get negative 110q equals negative 55p plus 55. Multiplying this one by 10, we get 110q equals 90p plus 50. Okay, we're going to add these two equations together by elimination method. My q's are gone. 0 is going to be equal to negative 55 and 90. What's that going to be? 90, basically 90 minus 55. Is that 35p? I think it is. And when we add these together, we get 105. So now we want to solve this. We're going to have to subtract 105 and divide by 35, and that's going to give us p. Simplifying this, divide both sides by both the top and bottom by 5, since they're both end in 5, we've got negative 21 over 7, which is negative 3. Okay, I am happy with that 35. You do a whole video, you start to stress out on those number skills. Now we need the q. So where's a nice equation I can plug p back in and get q? This one's got a couple of negatives, so I'm probably not going to put it into there. I'll probably chuck it into this one. So 9p. So 11q is 9 times p, or negative 27 plus 5. So 11q is negative 22. Oh, thank God, it's a nice number. Q is negative 2. So the line equation is negative 2y equals negative 3p plus 5. That is the line equation. And if you chuck that into Desmos, you'll see that it should go through those two values. Awesome. Let me know how you went on that in the comments below.